So we've made it. We've been building up to this for a few days now, but we finally arrived. We're going to talk about AVD today. AVD is our packaged Ansible collection that's going to wrap a lot of the primitives we've been talking about for the past few days. When we started this, we were talking about just configuring devices by SSH. Then we looked at how to do that with our APIs for both CP and US. Yesterday, we started looking at how to abstract that a little more with Jinja templates and Ansible. Today, we're going to show you how we take that all the way and do some really fancy tricks with those basic primitives. So when we talk about AVD, we have it on GitHub, we have it on Galaxy. You can think of it as a superset of roles to do configuration for EVPN, VXLAN, and other designs. When it started, it was strictly for DC L2LS and L3LS, but it's been getting expanded with additional designs over time, and that's likely to continue into the future. For an accurate listing of what's available in terms of designs, you should look at the docs and see what they have. But effectively, what we're going to see is that the designs in AVD are based on the white papers we publish around our recommended designs for various customer use cases. All of AVD is publicly available and customers are free to contribute to it. Most of the commits in a project are from Arista employees, but there's nothing stopping a customer from submitting a PR. Typically though, what they're going to be doing is opening issues for various requests they have or issues they found, and then we take and work on those and file commits that patch that. When we talk about the actual roles in this collection, there's quite a few here. Some of these are going to relate to what we're doing in terms of generating configs or pushing them for devices. Some of these are ancillary tooling that is not strict necessary, but nice to have. For example, this DHCP provisioner role will help you, if you use it, set up a local DHCP server and do some basic operations so that you can bootstrap your fabric. It's helpful when you're doing a from nothing DC deployment. When you talk about AVD versus just our Ansible collections, there's really a couple different things you have to understand. AVD is not just the modules we talked about yesterday that allow you to do operations against devices or CVP. AVD is an entire system and a methodology for how you define and think about your fabric. So there's a data model we have, which when you use it, it's going to give you a very holistic and easy way to think about the fabric in terms of tenants, services, IP addressing, all of that. It's easy to extend because of how we actually do our Jinja template construction. We'll dive into that more later, but just understand that pretty much every feature has its own template, and those templates get slammed into the overall EOS config template to make the actual outputs you'll see for your devices. We also produce the entire device config as files from AVD as well. We don't just load it into devices with those shorthand modules we saw yesterday. This is helpful for a few reasons. One, you can then commit these config files to Git and diff them across commits to see how they've been changing. Two, if you need to, for some out-of-band reason or something of the sort, you could copy and paste them into a system. And then three, you can review them manually and compare them with what you would expect to see in a CLI to determine if there's something that you messed up on your templates or your data modeling. And finally, one of the things that's really cool, and you'll basically never see in a network that's been mainly configured by engineers, is documentation, accurate documentation. Every time you're running Ansible for our AVD collection, if you're running the rules for this, we'll emit documentation that reflects what features you have configured, IP addressing, and all sorts of stuff like that for both the fabric and devices. Most networks you've seen in the past, they probably have some high-level documentation, but it gets out of date and it drifts over time as they update the configs and it doesn't change the docs. Because this is all part of the same playbook pipeline, you can be pretty sure, unless they've massively jacked up their playbooks, that the docs they have from AVD are the same as the actual configs they're deploying. If you haven't seen this before, this is our AVD logo, kind of illustrating to customers the main advantages of using AVD. Obviously, as we talked about, build, document, deploy, very simple. Integration of Cloud Vision, all good. Something we'll briefly touch on later, but not really get into because how complex it can be, is validation. We have ways to do both pre and post change validation in AVD and integrate with third-party systems like Batfish to do even more enhanced validation. You could have a customer design a pipeline that does something like from a data model, build configs and documentation, deploy that, and then run an entire validation suite, something like Batfish, to verify that all the routes are in place, everything works expected. And then if that works, leave in place. If not, roll back. That's possible. We aren't going to get too much into that because it'll take extra time to talk about Batfish. So when we talk about AVD and Ansible, there's a couple different pipelines we're going to discuss. I've included here an older pipeline for Cloud Vision to show what it used to look like. When you would run this entire playbook, what would usually happen is you start with your host and group vars, which you're familiar with by now. And effectively, you would have all your data in the model we expect. You load it in. You would use this role called EOS L3S VPN, and it would scaffold out a series of tasks to take your data, make your config files, make your documentation, and then you'd pass those files off to an EOS CLI config gen role, which would take further action to scaffold those into your actual EOS CLI configs and then deploy them. We've extended the pipeline by breaking out some of the roles in newer deployments. And I'm calling this the CDP pipeline because this can also be done with direct device interaction. But if you're pushing a Fabric deployment with AVD via CDP, this is what it's going to look like. Same as before, we take your host and group variables, we transform them with our EOS design role, and we emit documentation and config files. From those, we actually do the CLI config gen. With that, we'll then upload configlets to Cloud Vision based on what we've generated, and then we'll do the actual deployment, followed by post-deployment verification. And we can also give you reports on that as well in formats of your choice. So for customers who need Markdown or CSV for artifacts or change control, they can do that. And then this can be all one playbook. We'll dive more into the task and individual roles later, as well as some of the config file dynamics. Grant, you had questions yesterday about how we can do dynamic data structures. This will get into some of that.
Gotcha.
We can also, if we want to, leave CDP out of the picture entirely, and we can use AVD to deploy directly to switches. In that kind of pipeline, it looks like this. You'll notice here we've changed some of the roles we're using. We're not using the CDP roles. Instead, we have a deploy EAPI role that will push things out under the hood. That's going to use the EOS config module you might have seen yesterday as a part of a task to do that. Even with that, we can still do the same config generation, push it out, and then run reports. So we've given people these modular components via roles that they can use to compose pipelines as needed. And you'll see examples of that in playbooks today in various operations. So when we talk about our data modeling, what does that mean? Like we mentioned yesterday, one of the things we can do in Ansible with our Jinja templates is we can use a template to create a new data structure from a prior data structure. And we use and abuse that quite heavily in AVD to get the outputs we want. What you're going to see, and we'll show you through some of the repositories we look at today, is that we'll start with your usual host and group variables. We'll specify some defaults, give us some basic information, certain things like if you want OSPF or a BGP underlay, address ranges, things of that sort. We then take that, and with your inventory file, we can transpose that into a dynamic config structure for each device, where we'll do things like give IPs out for each interface. We'll set features, things of that sort. Obviously, when you look at this is not a config yet. This is still a YAML definition, but this then gets consumed as the input to a later role and a later task to actually emit your full config generation. And I'm going to drop a link in chat real quick to give you guys, you can look at some of this as we talk about what this looks like. 1 second. So if you look at this repository here, while we go through this, you can see some of what I'm talking about. And we'll break out the slides as well when I want to show you certain files. We talked earlier about how you can get nice, pretty documentation from AVD as well. This is an example of some of the docs you can see, and we'll show you more of this. But we can give you all kinds of nice summaries, like, okay, if your overlay, this is the range you give us for loopbacks. Overall, because it's /24, 256 available, we've assigned 9. Total IP address pool usage is 3%. And we can dump you tables and outputs of what IP is where and what loopback it's on, things like that. We'll dump you configs. We'll give you config examples. Like we mentioned, all this is done with Jinja. You're going to see some more interesting patterns with Jinja than we talked about previously. We've touched on some of them, like extends and blocks, but you're going to see how we really use those to make this a highly modular system. So again, like we talked about, when you're using our AVD and Ansible collection, you're not locked into one pattern. You can deploy manually if you have some reason for your network, typically be a highly restricted environment. You can do it via EOS direct deploy, or you can do it via CUP. You can also add any role you want in the playbook. You can do backfish validation. You could stuff data into a database. You could do some sort of client end-to-end testing if you need tenant validation in your network. All that can be done because of how this is scaffolded out with roles and tasks internally. Putting what we've been talking about these past few slides into more of a visual representation, this is what it can look like in various playbooks. Now, these arrow items here could be either done as plays or tasks, depending on how you personally structure your playbook, but the basic flow would remain the same no matter how you structure them. If you're doing just a basic deployment, you would spec out your description of the fabric, the variables, the IP ranges, underlay, overlay. You then run through the generate configuration roles and deploy it with the API. If you're using CUP, same for the first 2 steps. Then you actually do the roles to push your configlets and your mappings to CloudVision. You'd create your change control and roll it out. If you wanted to then stack on validation, you'd add 2 more steps. You do your validation here. We can emit reports, and you could optionally add on Batfish if you felt like that. You're going to hear me say Batfish a lot because it's a cool project and there's a lot you can do with it, but it's not something we integrate directly into AVD today because Batfish is all about customizing your validation checks to your environment.
So I have a question about roles.
Sure.
Can we think about roles as just modules which perform the specific tasks?
So the language is very important here because Ansible uses words that don't mean the same thing in Python, which gets confusing, right? If you're talking about a Python module, which is like a library, then yes, an Ansible role would be like a Python module. But a module in Ansible refers to a piece of code that tells Ansible how to interact with something, which is why a role is not an Ansible module. An Ansible role could contain modules.
Okay, I see.
Yeah, so that's why we have to talk about like what language and what tooling we're talking about, because a Python module is nowhere near the same as an Ansible module.
Okay, so it's a set of instructions which can include multiple modules. Yeah.
Right, and we'll walk you through what these roles look like under the hood in some of these slides we're about to jump into.
Okay.
So, yep. If we talk about the first and most basic role in our pipelines, that's your EOS designs role. What that's going to do is you're basically going to feed in all of your group vars and host vars we talk about. It's also going to take our implicit default mappings for the role, and it's going to slam it through a number of modules and tasks to then emit a set of facts. It's going to give you some fabric level documentation, and it's going to give you these EOS config files, which are YAML that will feed into a later step. You'll notice here I emphasized fabric documentation because this step gives you documentation at the fabric level. A later step will also give you documentation at the device level. When we talk about the inputs here, we have, as usual, our inventory file on the far right here. And then in group vars, we are going to have group level mappings that are going to have things like your fabric parameters for protocols in use, IPs, things like that. You'll have your connectivity mappings for spine uplinks and MLAG pairs and any services you have in place. That's more of an EVPN VXLAN thing we'll go into, but you'll see how that works. When we look at what that can look like within a group file, if you're looking at the repository I put in chat and you look at group vars dc1 fabric.yaml, you'll see an example that has this here on the right, but more of it. We'll jump out and take a look at it in a second as well, but I just want to walk through what we have in the slide. Within this group, we are setting up for L3 leafs that we have some default values in place now. We're going to be saying for the purpose of this, that this will be the virtual map we'll use for MLAG and other services. The spines are going to be uplinking to are DC1 and DC2, sorry, DC1 spine 1 and DC1 spine 2. All of the devices will use ETH1 and ETH2 to do uplinks to the spines, and they'll use ETH3 and ETH4 as their MLAG interfaces if they're a leaf pair. Looking at your node groups here, you'll see that we specified we have a leaf1 group of leaf1A and leaf1B, and some details about these. This is a lot, but we have very easy scaffolding around this, and this is all extremely well documented in our repository, and we'll get to that in a bit. But what I'm also going to show you here is what the actual role is doing under the hood when you run this. Because this will probably clear the question you had too, Anton, about what the actual role is doing. Like we talked about the other day, roles can have sets of tasks and templates. When we actually look at what happens when you call the role in a playbook, this is what's happening. Under the hood, when we run or import that role in the playbook, these are the plays that happen. So a couple of things you're going to notice. Obviously, we're doing a lot of Jinja templating within the playbook itself. But two, we're abstracting away quite a few plays from the user. They don't have to remember how to invoke these given tasks or what they have to actually do to make that work. All they have to know is, I have this input file, I run this role, and all this happens for me. So this is where we start getting into layering our abstractions to a point where now it's not just that we have an API in place to the device. It's not just that we have an Ansible collection using the API. We now have Ansible collections using other collections to do further abstraction. And this is what can make it so powerful. We're talking about deploying the entire fabric.
So each role is just another playbook.
That's one of the things it can be. There can also be some migration logic like this, where we have these upgrade tasks that can happen, things of that sort. But yeah, in general, a role is a grouping of plays and templates using those plays.
Okay, got it.
Mm-hmm.
And the modules are like Python codes. Like if you look at the CVP collection, everything is written purely in Python, and we don't have roles in that one. Well, we do have like 2 roles, but they are not really used. We mostly have modules over there.
Yeah, let me jump to this real quick to show you what that looks like. Where was it for this?
No, yeah, it's plugins, and then inside you have the modules.
I'm trying to remember my tree. So like Tomas was saying, under the hood, when you're using a module or a plugin in Ansible within your playbook or your task, what happens is you're calling something like this. And what this is just a Python file. So Ansible runs this Python code locally in your machine and things happen. But this is how we get from APIs to using them by YAML code in Ansible.
Okay.
Mm-hmm. So another set of inputs we can feed to EOS designs and expects is our tenant networks file here, because we specified that back in our inventory. What this gets used for is for our VXLAN and EVPN mappings. We'll specify here our base VNI per tenant, and then for our given VRFs within that tenant, we'll also map out those VRFVNI numbers and other tags or details about that. You'll see more of that in the repository we put in chat as an example, and you'll also be doing this part of your lab today. Once all this is done and you finish running the EOS design role, you get outputs like this for every single device. And this is how we start getting into talking about putting dynamic keys and values for devices, like you were asking yesterday, Grant. As you can see here, for this device in question, we've now mapped out things like the platform it's on, IPs in question. We'll have stuff like aliases, daemon configs, so on and so forth. What makes it dynamic too is that because the templates we're using, if we don't have a feature turned on for a device or we don't have keys, we don't have to emit them into this config file.
And so this leverages a template to actually create those dynamic configs.
Yep.
Okay. Okay.
So that's how we get around that little problem with Ansible where you can't share bars between plays and such. It's just, okay, well, I need the template anyways. I'll take my inputs, I'll run through a template, I'll make outputs to a file. Next role will then pull that file back in and do its work.
Gotcha. Okay. Could you do that within the same playbook? Like if you just had a long play?
Nothing stopping you. Just make 2 plays.
Okay, cool. Could you do it within the same play as long as we assume we're executing like, if we're executing in a list of those same tasks, they would be created and defined after that task is done, correct?
Yeah, you can. It starts becoming less useful if it's in the same play because you still have it in context, but you can do it.
Okay.
So again, documentation. Documentation is great, especially when you have to write it, it just happens. When you start looking at the Fabric documentation here, we have it for basically everything in the Fabric. And we'll jump out here to the repository I was showing you to give you an example of what that's going to look like. Within the overall repository, we have the documentation that was built, committed here to show you. So for the Fabric, once the actual design role has been run, you get a nice pretty markdown file like this, where it tells you for every device in your Fabric, this could be your management IP and the platform. This was done as a lab demo, so it's all VOS lab. But if you had a real Fabric and real devices, you'd have their various platforms. Then you have this nice topology table here. You would usually feed this to something else like Dot or other tools to give you an actual topology in a way you usually expect as a graph. But this will show you for any given device, the local interface and remote interface, so you can map this all out. And then of course, we have the IP addressing as well. This is all given to us, quote unquote, for free by running that role. We didn't have to think about the docs. We didn't have to create something for them. It just happens. And docs that are free are more likely the docs that customers are going to generate. And so that makes them useful. So looking at example playbooks here, What does it take to actually do everything we just talked about? Very simple. We run one task in one play. What happens is you have a task, we use this import role, and we tell it, hey, pull in EOS designs and run that. You'll notice here I've got this collections keyword, which is basically pulling this into my namespace to search. If you want to think of it in DNS terms, it'd be like a search domain. So Ansible will look through arista.avd and it'll find arista.avd.EOS designs and run that. And then like we showed you earlier in the GitHub repository for this, under the hood, EOS designs then runs through that set of tasks and plays we showed you, and it does all its scaffolding for us. So this very simple 10-line or so playbook is doing a whole lot of heavy lifting for us. Questions about import role? This is the first time we've shown this keyword, I believe. Okay, sounds good. One thing to know as well, it's not just roles you can import within a playbook. Playbooks can also import other playbooks or tasks. Typically, you won't import a task list. That's a little more generic, but you can absolutely build small playbooks and then scaffold them into bigger playbooks. Very useful if you've got reasonable components. Moving on, the next role you're going to see used in pipelines is the EOS CLI config gen role. And what this does is this then takes all those nice dynamic YAML files we've made in our previous step, and we hammer those through Jinja templates, and we get actual text configs for devices that we can then paste into them or deploy. This is also the step where we will then deploy and create device-specific documentation. And this comes in more detail than what you've seen with the Fabric documentation we showed you earlier. We'll get to that in a second. But the main thing it's going to do is you can see things like all the services you have on a given device, all the configs in place for that, in a very nice and easy to look at format. So when we look at what we need as inputs to this role, it's what you give as the outputs in the last one. So if you run them back to back, they just work. What you're going to see when you look at these files overall, we try and structure the variables that we emit in the order the CLI syntax, not alphabetically. So if you know the order of EOS syntax, you can look for it. If not, Control F. Obviously, EOS syntax also changes between releases sometimes where a keyword will exist. So it's not always an exact match. We try and keep it close to the latest, but it can differ somewhat. And like it says here, all values are optional. If you don't specify something and we need it, we pull a default. If you didn't specify something and we don't need it, like an optional feature, you just want it turned on. So we're going to show you this documentation as well because it is massive, but everything that you can feed our data model is documented here on GitHub. And we'll show you this. So this README for this role will list out every single thing you can configure and feed to the Ansible role to get an EOS config. As you see here, we're just in the table of contents right now, but you can already see we have input variables for just about everything. And when you scroll down into the actual features, we'll show you examples of what the data model should look like for a given item, like an access list, what we allow, and what you can spec. Obviously, this can look a little verbose, but remember, we're doing a lot of Jinja scaffolding. So even though the output is verbose, the inputs can be very terse. And of course, customers can do additional Jinja templating as well. Like let's say feed a text file as an ACL and have it then emit an access list in this format we need. So it's very flexible in that way.
Then, just a quick question. So unless say customer wants to change the internal details and not just use the plain AVD as it is, they would never have to look into this role by themselves, right?
Right. So yeah, so let me go back to our pipeline here. If they don't want to change anything, they just want a bog standard L3 LS deployment, that's very simple for them. All that had happened is, let me go back to this to show you. All that happened is they would, in this very first step here, they would define their host and group vars, and they tell us a few things like the range to use for the underlay protocol, overlay loopback addresses, things of that sort. And then we just go designs, config, deploy. They don't have to change anything in between.
Got it. Got it. Thank you.
So after that's all done, when you finally run through this CLI config gen role, your outputs are going to be config files. As you can see, they're US config files. Name is on the tin. What you also get, and we'll look at this a second here, is this documentation. We've talked about it. It's pretty, it's automatic, and that makes it good. So let's go look at that. For any given device here, like we'll pick this one, you'll see, of course, you've got your basics around your management interfaces, if you're in a VRF or not, and your basic gateway stuff, as well as the configs that should be on the device. And then you've got your basic configs for formatter and things like that. Any feature you have in the box, like your DNS name servers, NTP. And then you'll have things that are more important to end users, typically like the VLAN table of what VLANs are deployed on the switch, and if they're named trunk groups, things of that sort. You'll also get to a table of Ethernet interfaces, and we'll give you some nice details about, okay, is this L2, is this L3, is it part of a port channel, what VLANs are allowed there, all of that. So we've had these very nice summary details. And if you have a customer that's deploying things to AVD and you're trying to troubleshoot their fabric, you can ask to look at their device documentation because they'll have it for free. And unless they've made manual changes to the switches, this will be accurate. If they've made manual changes, it can be off, but they really shouldn't be doing that. The entire point of using AVD is that you deploy this all automatically, it's up to date, and it's easy to manage. So again, to run this and get all this goodness, it's very simple. We just pull in the role. And obviously here, this is again, just a one playbook, but we'll show you at the end, and you'll see in the lab what this looks like when you tie it all together and run it in sequence. So at this point now, we've taken our basic data model, we've created configs for devices, we've created the configuration files. Now we need to go and deploy it. We need to actually get the content out into our fabric and make it usable for the rest of the enterprise. Two ways to do that we've talked about. We can use eAPI and directly deploy to the devices if we don't have CVP or we don't want CVP, or if we do, we deploy our configlets to CVP and do a change control from there to drive our fabric state. Again, the inputs to this role are the outputs in the last role. So if a user does not need customization, it's very easy. They just move along and they'll pick it up. If you deploy with this eAPI deployment role, or we're doing it directly, we'll give you a couple of different outputs. We're going to actually run and take a snapshot of the device configuration before changing it. And we'll give it to you as a text file on disk in case you need to roll back for some reason. We'll also give you the config after we're making a change throughout the push to the device. So you have both a pre and post config file you can use if necessary. And again, that's gonna look like this. So step one, when you're using this module, we go up to all your devices in the fabric and we build config backup files. Then in step two, we take your config files you built, we push into devices, and then we read the running config back and we write that to your post change backup file. Any questions on this part so far? Okay, sounds good. When we look at the EOS deployment, that's going to be a slightly different workflow. In this here, we're going to start by reading your inventory to get details for where CP is, how to talk to it, all that goodness. And then we're going to grab your EOS config files as previous. We'll push into the devices here. What we're going to do is we're going to use these modules under the hood to go and build per device configlets and then map them to your devices. At that point, then within CloudVision, when we do that, they'll generate a task per device because the DC won't match the RC. And then from there, the user will do a manual change control in step 5 here. And at that point, then you'll actually have your changes in the fabric. A couple reasons why I want to do it this way. People sometimes ask why we use CVP with Ansible at all. Again, like we talked about in day 1, if customers have more intricate change controls, or they have to do something like deploy A side and then B side and validation between, that's something that CloudVision can coordinate very easily, whereas it's not as easy to do in Ansible, and we don't provide roles to customers to do that. If they want to do operations like image pushes, that's handled by the CVP, things of that sort. So that's why we have the extra complexity of putting CloudVision in this Ansible AVD workflow.
Do we have a role or a built-in module that we can run that change control from Ansible if we were just like super lazy and didn't want to touch CloudVision at all?
So the answer is yes, somewhat. I think I put some slides yesterday because of time, but there is a module for CVP where you can push a task. When you map configlets, one of the outputs you get back from that module is a list of tasks that have been built in CVP now. And then you use the task module to execute them. The trick is,
we also have the change control now.
Oh yeah, okay,
So
that's true.
we
We did have that.
Yeah, we have that.
Yeah.
And on the AVD side, we have the execute task equal true, which creates a change from each task. It will create a change and executes it.
Mm-hmm.
Because sadly, we still allow that.
Yeah, and what Thomas mentioned there, like we used to do in the old format, is you would do execute task was true or state it was executed, and we would just push it. It was a very simplistic change control, no kind of coordinating, no group coordination or anything like that. It would just be these tasks, run them. So that's why previously we would recommend the customers to manually do this change control to get more control over it. But we now have new modules in place that allow them to do that. And like I mentioned yesterday, at this point now, we have the V3 modules for these. So customers can the V3s really.
So the Ansible AVD inventory to container, that module just creates the containers on the CVP based on our design, or if let's say there is already a mapping for some of the devices and I'm changing or adding some devices, will it just look through the CVP containers to make sure that the containers are how they should be?
The simple answer is we can do both. But if you look at this module, and we can jump into that later, what you'll see is that, I think we might rename it now, but you can tell it to either do, given a list, make sure only those modules, only the containers are there, or given a list, make sure they're at least there. Basically strict or loose mode.
Got it.
And then of course, when we're looking at our task again, fairly simple. Here we're just pulling a few more collections during deployment, and then we're also feeding some bars. My indentation is off here. I should indent these, but we're feeding these to the role to operate with. And then once we've actually entered deployment, at that point, it's time for us to go through and make sure everything went okay. We already do this at a basic level in the Ansible modules with those validations, but this is where we actually take it and make it a more formal document to look at. In fact, what we're going to do here is we pull those config files again, we pull the state of your devices in the fabric, and then we emit CSV and markdown reports for you, and we store them in this reports folder in the directory you're running your Ansible playbooks from. Again, we're just importing the role. Importing roles like this makes it really, really nice and simple when we're doing these kinds of operations. So let's talk about if you wanted to extend our config gen. Let's say you have something where you want to add a feature or you need to change how it operates. It's easy to do. We provide a few basic guidelines to people about how we ask them to do that. In general, we try and use Booleans and not the state variables. That's a Ansible thing. Use new syntax. Don't use the old, obviously. Soon won't matter anyways. The only supported code will be in the quote unquote new format. And then like we mentioned earlier, keep your variables in the order where they appear in the CLI, not alphabetical. The final thing you're going to see us a lot in when you look at the templates directly is you keep the features optional. We guard them in blocks like this, where we'll check if it's defined and if it's not, none. Only then will we emit configs for those features. We talked earlier about how we're doing some more advanced Jinja operations to make our templates extensible. This is what it looks like. Within the overall template, what we're doing is we have each feature broken out into a subtemplate, and then it gets loaded in. So by doing this, we can keep each feature template itself small and composable, and then it gets loaded into this for the actual composition. That way, someone doesn't have to look at a massive templates, thousands of lines long with control logic for every feature. They just work on their self-contained subfeature, and then it gets loaded into the overall template. If you're looking for paths on these, here's what some of these are. We'll of course put the link to the AVD repo if you need it as well in the chat. The overall AVD site is just avd.sh. And then again, if you're going to be writing extensions for AVD, or if you want to contribute to a project, we just look to see if we can keep certain patterns in place to keep the template syntax the same and reasonable. And then I'm going to skip past some of the guidance server doc stuff I have them here so you can read through these if you want to contribute to AVD, but it's not strictly necessary for today's work. One thing you'll see that we do ask as well, though, is when you are writing for config gen, we also need to write documentation. Because we mentioned, the documentation is generated automatically, is quote unquote free for customers, and it really helps us ensure that they have good docs, they'll use them, and then if we have to troubleshoot AVD Fabric, we have good docs available to help us. So, lab time for the day. As usual, answers are in a separate branch. Today's lab is written by Tomas. If you're going to clone this repo into your environment, we do have an overall repository for the 3 days that we're going to be using as well. We just finished it this morning, so we've linked the direct one here. Keep in
Actually,
mind that,
can't I already clone the training repo? Because I've made some changes already on that one, and we
can
pushed
give
it
that
already
one.
there. So that should just that should just
All
work.
right. Well, yeah, 1 second here. I'll change this then so you guys have that. So we have 3 labs today that you're going to run through with AVD that Tomas has tested out. One thing that we did observe is that just due to the ATD environment, these labs might take 40 minutes to run through your playbooks or so. So be aware of that. This will be the repo you're cloning. We'll update this, and then we'll show you what you're doing today as far as tasks go. So lab 1 is pretty simple. You're going to run through a basic AVD deployment. More detailed instructions are in the day 3 folder with the README that Tomas has provided for you there. You have some basic files in place. Once this runs through and you have the entire playbook operate, do some basic sanity checks, and we provided you with static configlets for host 1 and host 2, so you can actually use them for ping testing. It configures some basic connectivity and such. So once the AVD playbook is run, you'll run the playbook specific for host 1, host 2 configlets to deploy it through CVP in the environment. For lab 2, you're going to add a new zone to a tenant and then verify that you have connectivity between hosts there. For lab 3, you're going to go back and modify the inputs to enable AAA across the fabric. So overall, this will be a good example of what it takes to get AVD running. The longest part of this, unfortunately, is just the execution time. What you may see as well when you're going through this is that for some of your devices, Terminator might fail to come back up due to just CPU memory load. If that happens, let us know. We'll try and help work around that, but some of it's just due to the resource constraints in ATDS today. Any questions on so far before we get started with this? All right, sounds good. Then we'll stop recording and get to lab time.